started and they can catch up. My name is Carrie Christensen. I actually work with the Orange County Department of Planning, and I also am board support to the Orange County Municipal Planning Federation. As mentioned in the course description, this is the Federation's first webinar, and we're excited to be able to offer some educational classes again. COVID kind of put us down for a little bit, but we're going to try our best to gain steam and keep on moving. We are hoping everything runs smoothly, so please be patient with me if it doesn't. Just a few housekeeping items. It looks like everybody has already, but if you could just make sure that your name is showing, just so I can keep track of who has attended, just in case any kind of certificates are needed for the proof of credits. And I would say any questions that everybody has, if you could just use the chat portion of Zoom, and we will take them as they come, or if Candace wants to take a break, we'll figure out what works best. I am also going to send all of my contact information at work through the chat, but if everyone has a pen handy, my direct phone number, just in case everyone has questions, concerns, comments, or may need anything for their boards, I could be reached at 845-615-3866. Again, 845-615-3866, and I will send that along with my email address right in the chat. And I guess without further ado, I would like to introduce Candace. She's with NYSERDA, and she's a senior project manager, and will be putting on tonight's presentation.
Thank you, Carrie, and thank you for inviting me to present to the Federation. I will be speaking tonight on the Battery Energy Storage Systems Model Law that NYSERDA has published. It has been out, I think, 2 to 3 years now at this point. And I will start sharing my screen. All right, can everyone see the screen? Perfect. This also has so on our clean energy siting team, which I work on, we're a team here at NYSERDA, we have a general mailbox that goes to all our emails, which is cleanenergyhelp@nyserda.my.gov. I will also have that up at the end of the presentation, and we'll also drop that in the chat, as well as my personal email if that's beneficial to people as well. So for an overview of what we will be discussing tonight, first we'll start with an introduction to battery energy storage systems, kind of build the foundation of what are these systems and why are they coming here, an overview of the New York State goals, programs, and policies, and then move into the actual battery energy storage systems model law, and also touching on the fire safety requirements that are currently in place with the Uniform Code. Let's see. So to start, we have here, we'll talk about what energy storage is. So energy storage utilizes the concept of potential energy, which is energy contained within an object or material based on its composition. Once stored, that potential energy can be dispatched for future use as needed or as available. There are a number of different types of energy storage systems which can store and dispatch different forms of potential energy. So there's electrical energy storage, and what we'll focus tonight on, and this utilizes the potential energy of electrons. When a force is applied to those electrons, it causes them to act in a certain manner, releasing electricity. So this is basically your standard battery that we're all very familiar with. Another type of stored energy is the gravitational energy storage that uses potential energy of gravity and consists of releasing or dropping something from up high using the force of the falling object to generate electricity. So an example of this would be like a pumped hydroelectric facility. There's also the mechanical energy storage, utilizing the potential and kinetic energy of a moving object. Some main example of this is flywheels, which are vacuum chambers that charge up and spin a heavy rotor at high speeds, utilizing a generator to convert that mechanical energy back to electricity. And the last most common form of stored energy is thermal. So thermal, like using electricity to make ice when electricity is cheap, and then using it to cool buildings when prices or demands are higher. But like I said earlier, the main focus of tonight's presentation will be on this electrical energy storage. So as I just mentioned, we'll be focusing on the electrical energy storage systems, and more specifically within that, electrochemical energy storage systems, also known as batteries. So the most common battery, like electrochemical makeups we see now, are lithium ion, lead acid, which I think everyone is probably very familiar with, nickel-based, and flow batteries, which I mentioned previously quickly. So the lithium ion is the most prevalent that we've been seeing and is being deployed across New York. It's also the battery that's in your iPhone. So it's kind of everywhere we're looking at this point. And so for the building blocks of energy storage systems, how they work is first you have the cells. They're the individual units that consist of an anode, a cathode, and the electrolyte. So that's, your kind of standard AA battery you can imagine as. And then a grouping of cells is often referred to as a module. So this can consist of a number of cells wired together in series or parallel, and it's capable of storing and dispatching energy. So more of this middle picture here that says Panasonic. And lastly, finally, a grouping of modules is often referred to as the battery energy storage rack. So you can see all the way to the right that there are several modules in this container, and that would be considered a battery storage rack. This is another similar graphic visualizing that battery cells can take a number of shapes and sizes. You can see the cells, you have the cylinder ones, they could be a prismatic, it could be pouches. And once those are wired together, that's when they become being called a module. And then once again, once the modules are all wired together, you have the battery rack. So the next things we really want to look at least in this chart, is the lithium ion column. This is really trying to show why lithium ion has become so popular for these larger energy storage systems in the recent years. The lithium ion, they have the higher round trip charging efficiency, meaning that they're losing less energy every time they do a charge cycle. So their efficiency is higher than majority of the other batteries. Their costs, they have very low operating costs once they're installed, but do have definitely a high upfront cost. The space required is pretty small. They have an extremely high energy density relative to other forms of energy storage, and they are becoming quite mature as they're being widely utilized with high market penetration, including electric vehicles as well as consumer electronics. So while the lead acid battery has been primarily what's been used in the past, there has been a pretty large move over to the lithium ion with these recent technology advances, and to help assist renewable energy and other states and national goals and targets for larger energy storage systems. So this, we can see here what battery energy storage systems look like on, a completely put together scale. So you can see on the left, you have what looks like a residential system, then a slightly bigger commercial system, and on the right is the utility system. So you can look at these storage systems solely based on size and function, which would be that residential, commercial, or utility scale, or you can look at them how they relate to the electric grid. So normally residential and commercial systems will be behind the meter on the customer side, while those larger utility size systems are on the front of the meter, so the utility side. And lastly, to just really give a good impression of what these battery energy storage systems look like. To round it out, this is the battery management system, which is probably the most important aspect of the entire system. So this is what's monitoring each individual cell within the system. This will alarm if there's any potential issues, if the temperature is fluctuating inside the rack, and is able to isolate affected cells or modules from the total system. So it's really the brains of the energy storage system, and also able to alarm if there's any abnormalities that are currently happening within the system. So this is definitely extremely helpful and important. So those are how these systems are designed. And now we'll talk a little bit about different applications for energy storage. So this is a high-level snapshot of the grid of the future. We'll get into a bit more detail on some of the specific functions that storage can serve. But from this bird's eye view, you can see that you have basically either the electrical grid right here, or renewable energy generating facilities that are then providing energy to charge the battery storage. And then that energy that is stored within the battery could then be used to directly power homes and businesses, or can be sent back to the grid as needed. So this is just a really high level of how this storage is being utilized with the grid. And now to get into more of the nitty-gritty.
Excuse me, Candace?
Yep.
We have received 2 questions. Would it be okay if I shared the presentation with the attendees afterwards?
Yeah, that's no problem at all.
Fantastic. I will send it out to everybody tomorrow who has attended tonight, just so everyone can review it, all the information.
Yeah, that sounds good. And it definitely is sometimes sounds like I'm talking about in another language when I'm speaking energy storage. So I usually say this too, take this as an introduction to myself and my team. And if you have questions that come up tomorrow, the next day, or want us to meet with your town, like, we're always happy to do that. All right, so continuing with the different applications for energy storage, it's really separated into 3 separate groups. And that is the customer services, the utility services, and the grid services. And they have there's, I think, like about 4 or 5 that are pretty specific in each group, which we'll go into a little further right now. Next slide. So first is the customer services. So this is application mostly for residential or commercial customers. I think the most obvious one that people think of a lot when they hear of energy storage is utilizing it for backup power. So you'll be able to power at least your most specific outlets and whichever during outages, so you don't have to rely on backup diesel engines or other things along that nature. Another application here is for increased PV self-consumption. So if you're paired with solar PV, the ability to better utilize your own generation. If you're producing a lot of energy during the day on your home system, you might not be using it all at the same time. So having that the storage backup will allow you to utilize that maybe later at night when you're not producing as much power. And then there's the demand charge reduction and the time of use bill management applications, which are pretty similar. So it's mostly shifting your consumption to save money during periods of high demand. It's also known as demand or peak shaving or load shifting. Next, we'll talk about the utility services. So distribution and transmission deferral. So divert costs of upgrades to utility distribution and transmission infrastructure. And what this means is there might be a really expensive upgrade to the grid that needs to happen, but having those larger bulk energy storage systems may either defer the need of that upgrade off a few years or actually make that upgrade need smaller than it would have been. So they're able to help the utility basically better plan for their own grid services and upgrades. And then there's also the transmission congestion relief, which will help mitigate congestion in areas with lots of generation or inadequate transmission capacity, and then resource adequacy, basically making sure there's enough capacity on the grid to keep the lights on. And the last kind of application topic is the grid services. So energy arbitrage is usually the most common one people hear about on this topic. So like charging when electricity cost demands are low and discharging when they're high. So to utilize that feature, you'll see people who are charging their energy storage systems at night when the cost of electricity is really low, and then discharging it when the demand is higher during the day. Then you also have the spin and non-spin reserves, which is to dispatch energy as needed to ensure that the grid supply equals demand. And then the frequency regulation to quickly ensure generators are synchronized for grid stability, similar to the voltage support, provide and absorb voltage as needed for grid stability. And then what's considered the black start, help large generators come online following a system failure. So there are a lot of different applications that energy storage is currently being used for across the board. So that is kind of why you're seeing more storage systems coming into your jurisdictions. Another example we have here is for peaker replacement, and probably one of the more important examples that energy storage can be used to replace fossil fuel peaker plants. Peaker plants sit around often unused most of the time, waiting for the specific hours or days when the load on the grid is the highest and they're called upon to be used, which sometimes might not happen for an entire year. So they're just kind of on standby waiting to be utilized. So energy storage has the ability to replace these plants, and then also their utilization can be used for other services at the same time. So while a peaker plant might be able only to meet those peak demands or emergencies, the energy storage, as you saw, has a lot of different applications that the utility could utilize to help its grid. And I also see we have a question about lithium ion stability in large arrays and what are the heat and fire hazards, which is a great question. And we will get to that closer to the end of the presentation. And we'll walk through the different, basically the risk and how the different requirements in the code are put in place to help mitigate those. So we'll definitely get more in depth in that later in the presentation. So next we will discuss the overview of New York State's goals, policies, and programs. Basically, why is energy storage being pushed on New York's level? Why is it important? Why do we need it? And what are the policies and programs that are currently put in place? So as many of you may know, New York State has some ambitious goals that will shape our energy climate future. So I'm just going to give you a quick introduction to some of the key policy mechanisms that have shaped or are shaping the state in this area. First, there's the Clean Energy Standard, which was adopted in 2016 and was designed to fight climate change, reduce pollution, and ensure diverse and low carbon energy supply for New York State. This standard set forth a framework for achieving a number of key goals, most notably 50% renewable energy for New York State by 2030. In 2019, the state then passed the nation-leading Climate Leadership and Community Protection Act, which strengthened some of the targets in the Clean Energy Standard, including upping that number to 70% of the state's energy from renewable sources by 2030 and achieving 100% carbon-free energy sector by 2040. One of the key vehicles supporting these policies is the Clean Energy Fund. So this was a 10-year, $5 billion funding commitment to help reshape New York's energy efficiency and renewable energy and energy innovation programs, with the goals of reducing cost of clean energy and accelerating adoption. So in the next few slides, we'll talk about some of the major programs that have come out of the Clean Energy Fund and also the Climate Leadership and Community Protection Act and the Clean Energy Standards. So the first we'll jump into is what NYSERDA calls our large-scale renewables program. So there is an annual solicitation issued since 2017, and these projects are for wind, hydro, solar, and as you can see, at least for the award group of 2020, majority of these projects were solar projects. These are projects you're usually seeing that are like 20 megawatts and up, so they're usually around 100 acres or so and larger. I don't believe there have been any that have been awarded by NYSERDA in Orange County, though there looks like there might be one close on the line. And you usually see these more in upstate and Western New York. And then it's also, I think, worthy to note that energy storage systems, they're only awarded through the large-scale renewable program if they're paired with a solar project. So those large energy storage projects do not go through this solicitation. And as you can see, there was 21 solar projects and only 2 of them at this point were co-located with energy storage. Next is the New York Sun Initiative. This is a program that I think in Orange County has definitely seen a lot of those projects coming to them. These are more of your 2 megawatts to 5 megawatt community solar projects. And New York Sun, it's a $1.6 billion initiative to advance the scale up of solar and create the sustainable self-sufficient solar industry. So in our latest targets is to hit 6,000 megawatts of distributed solar by 2025. The goal was originally for 3 megawatts by 2023, but we decided we only apparently needed 2 more years to double it. And then the governor earlier this fall had announced trying to strive to hit 10,000 megawatts of distributed solar by 2030. So New York Sun has recently published a roadmap that is out for public comment on how those goals will be achieved. And it definitely has a bigger focus on disadvantaged communities and how they can get a larger benefit of the renewable energy projects that are coming online. And lastly, why we're all here tonight, the exciting stuff. So the Energy Storage Initiative here at NYSERDA. So advanced energy storage will play a critical role towards achieving the state's goals that we previously discussed, recognizing also that time and location of energy generation is critically important. So the Energy Storage Initiative has some major goals of their own. So their goal is to hit 1,500 megawatts by 2025 and 3,000 megawatts by 2030. In the latest state of the state, the governor proposed increasing this target to 5,000 megawatts by 2030. So the team at NYSERDA is currently putting together a roadmap themselves to figure out how they'll be able to meet those goals. And a big part of energy storage is assisting the intermediate energy of renewable energy. So the wind that's not always blowing and the sun that's not always shining, energy storage can really help those projects and become more valuable to the grid. So you're really also at energy storage, the benefits, you're avoiding CO2 emissions, reducing the impact of outages, and there's a large goal to create 30,000 jobs by 2030 in New York. And then through the NYSERDA opportunities, there is an incentive program for retail bulk, standalone, and storage plus solar incentives, as well as they provide technical assistance for developers on permitting, interconnection, customer acquisition, and financing resources. Our team, the Clean Energy Siting team, are basically the technical assistance for local governments who are dealing with energy storage in their jurisdiction. And here is the energy storage deployment in New York State. It seems like I have to go have a conversation with our storage team because they haven't updated these numbers on our public facing website in a little bit. But as you can see, there's definitely a lot of storage going in Orange and Rockland utility area and downstate, as well as in Western New York. So next is the team that I'm on, which is the Clean Energy Siting team. So as many of you may know, over the past few years, NYSERDA's Clean Energy Siting team has been traveling across the state to work with municipalities one-on-one on issues related to clean energy development in their communities. I know working with Kate Schmidt over the years, we've done a lot of workshops in correlation with Orange County for the past few years, starting with our solar guidebook and all our resources we have there, and now moving on to our energy storage resources. We've definitely have moved a little less from traveling around the state and are able to do this virtually from home, which is always a little more convenient to reach a bit more people. But like I said, we'd be happy to come to your town and work with your board specifically to help answer any questions that you may have regarding basically anything regarding clean energy development in your jurisdictions. We really see our role as providing objective information, support, and guidance to help communities make informed, localized decisions, focused on not only resource development, but deployment and working closely with local officials. So yeah, a big component of our resource development has been our clean energy guidebooks. Like I said, we started with the solar guidebook, I want to say 5 to 6 years ago at this point. And after the success that had on the market and the local communities, we started developing our energy storage guidebook to kind of get ahead of the curve of the storage deployment that was happening across the state. So we're happy to have any conversations and work with you guys directly on our resources. And we're also happy to continue hosting workshops on the county level as well. So as we are talking about batteries tonight, this is our battery energy storage guidebook for local governments. The first chapter is the battery energy storage model law, which we will be going into specifics tonight. We also have a model permit. Some of you might be familiar with our unified solar permit. This is a similar one, just hitting the notes for energy storage for basically any project under 600 kilowatt hours, which is basically your small commercial or residential projects. We then have our battery energy storage inspection checklist, which is an electrical checklist for the similar size projects. And lastly, we have chapter 4, which is excerpts from the 2020 New York State Uniform Code, which I made our colleague go through the entire code and pull out each section so it'd be easily found for local government officials. So while it might not be completely all-encompassing, it definitely has majority of the highlights of the code requirements for energy storage. And then next, this is our clean energy siting homepage with the link right there. You can find it at nyserda.my.gov/siting, which I can also share in the chat or have sent out to everyone tomorrow as well. Here you can find our energy storage guidebook, our solar guidebook, and a bunch of other resources that definitely would be helpful for you and your jurisdictions. Once again, we have the Clean Energy Help email address where you can send us any and all questions and we'll be happy to assist you. And then there's another section where you can request technical assistance and also see the courses that we are offering.
And then,
Hi, Candace.
Yes.
There are a couple of questions that have come into the chat.
Let's see.
All right, so there is a question about high voltage lines in our area and where we can get clean energy guidebooks.
So let's see, for high voltage line, I'm not exactly sure. I'd have to go and look to see where that would be. I mean, I'm sure it's probably still there. That was just the maps I was showing where deployment was. And I know a lot of the larger scale projects is just difficult to find land in Orange County that could handle that many continuous acres. But if you send me an email after this, I'm happy to see if we can figure out where that is in your area. Let's see. And then you can find our clean energy guidebooks on the website I just showed. And if you would like it hard copy one, you can just send us an email after this presentation and we can mail some to your jurisdiction. I also see there's a question regarding basically how to fight these batteries if there is a fire, and what do you do? So we won't be getting into the nitty-gritty of that tonight. We'll be kind of sticking on the kind of law components and the code, but we do have another course that we offer, which is more directed towards first responders. We actually work with a retired lieutenant of the FDNY, Paul Rogers, who works with us to give a presentation, which is more focused on incident management and kind of protocols. So if that is something that is of interest to your town specifically or on the county level, I would also recommend reaching out to me and we can kind of work more directly to set up another training that would really be helpful for the first responders in the area.
Thank you very much.
All right. All right, now the fun part. So we'll now start discussing the battery energy storage system model law. So up until this point, we've kind of discussed what are batteries, how are they assembled, how are they being used currently, and then what are New York State's goals and programs and policies in place to get these projects coming along. So I think we have a good foundation and understanding of why this is happening. So I think at this point, getting to the model law and seeing what you can adopt on the local level is important to make sure that these systems are being installed responsibly in your jurisdiction and basically in line with your community character. So if you have any familiarity with our solar model law, this has a very similar outline. You have the section 1, which is the authority. Section 2 is the statement of purpose. Section 3 is the definitions, going on the applicability, general requirements, permitting requirements for tier 1, permitting requirements for tier 2, safety, permit timeframe and abandonment, enforcement, and severability. So we'll kind of go through each of these sections, some more in depth than others. So the first section here is the authority. So this references the appropriate zoning statutes in New York Municipal Home Rule Law, which enable the adoption of zoning ordinances such as this. So basically you would just go through this section as you're adopting it and select whichever one of these ordinances is the correct one for your jurisdiction.
It does. So.
Next, this is the statement of purpose. So I always think this is a really important section of the law for town while they're adopting it, really to show what the town is trying to get out of adopting a battery storage law, and what's the purpose of it. So these are a few examples that we've included in our law, which one purpose could be to provide a regulatory scheme for the designation of properties suitable for the location, construction, operation of battery energy storage systems, to ensure compatible land uses in the vicinity of these areas affected by storage systems, to mitigate the impacts of energy storage systems on environmental resources, such as ag land, forests, wildlife, whichever. And the last one we provide is to create synergy between battery energy storage system development and, what other stated goals might the town be pursuing in its comprehensive plan. So here you at least, you get to put forth, this is why we're adopting this law and what we're trying to get out of it. So I won't go through all of the definitions because some are extremely boring and straightforward, but what we've kind of determined as the most important definitions for the applicability of the law is defining tier 1 and tier 2, which are separate system sizes for storage systems. Like I said previously, this is also similar to our solar law, which currently has a 3-tiered system for different permitting requirements. So within this law, we're really looking at tier 1. So this would be any system that is less than 600 kWh. So this is going to be your residential and small commercial systems. And tier 2 is basically everything larger than 600 kW, which is your large commercial and utility scale system. We do get asked a lot about system sizes and why they're broken up as they are around that 600 kWh threshold. That distinction is based on the code requirements in the Uniform Code, all of which we'll discuss a bit later. Basically, this distinction in the Uniform Code is that anything above 600 kilowatt-hour threshold must meet a higher, more rigorous standard for fire safety. So we'll discuss that a little further on. So section 4, this is the applicability. I think it's kind of rather straightforward. The requirements of this local law shall apply to all battery energy storage systems permitted, installed, and modified in the town after the date of this law is, passed. Battery energy storage systems constructed or installed prior to the effective date of this local law should not be required to meet the requirements of this local law. And then another provision regarding modifications and retrofits. So next we have the general requirements for this. So basically all energy storage systems will have to receive a building permit and an electrical permit. And then going through that, different energy storage systems just basically have to meet the Uniform Code and the Energy Code where required, and just really drilling it down that if you need to meet these other requirements, you have to go through the processes. And if there's any other, general requirement you normally have on your town that you require for specific projects, this could be an area you would add that in as well. So next we'll discuss the permitting requirements. So this, for the permitting requirements for tier 1 systems, which are residential and small commercial, you'll have to meet the battery energy storage system permit and the inspection checklist, as well as the applicable fire code. And for the tier 2 systems, now these are your larger commercial and utility systems, you'll have to get a special use permit, go through site plan review, and meet the applicable fire code. And we'll get into more details on each of those next. So here are some examples of tier 1 storage systems. A few of these are actually New York State installations. And these, I think you can tell over here, is more the residential application, and this being a small commercial application over here. And these are tier 2 systems, so more your commercial size and utility size. So these are more of you'll see like the shipping container size, or these over here on the left side with the governor, those are the power packs, which you can see they're quite tall. They're definitely hovering over her. So these are definitely a bit larger of systems. And I'll let you take that in as I have a sip of water. All right, so as I said before, the tier 1 system would have to meet the battery energy storage permit. So we have a model of this in our guidebook, which you can use and make completely customizable to your jurisdiction and how permits are normally issued. But this comes pre-packaged basically of all the requirements that you may need to do so. And there's a lot of customability here. So as I said, this shows like this application form with all fields completed, bearing relevant signatures, what the permitting fee might be. You can update for your jurisdiction, enter how you take payment methods, and make sure they provide the required construction documents, and also how they're going to be submitted. So this is a part of the actual application page. So they'll have to provide information regarding the property owner, the existing use, the system capacity, how is it configured, the type of battery, is it indoor, is it outdoor, just providing a lot of that system information upfront as part of the application. And then there's all the submittal requirements that are necessary. And this goes through general requirements as well as different fire requirements, debating if it's a commercial or residential system. So I definitely recommend for everyone to give this a look over, and maybe it would be a fit for your jurisdiction, and we'd be happy to help. Basically, if there's anything you're looking to customize on it or make it your own, we're happy to be a sounding board for you.
Hi, Candace.
Yes.
There is a question regarding the tier 1 facilities that they don't appear to be in a room as indicated by the code. And why is that?
I don't believe there is a requirement in the code that they need to be in a room. They are able to be outside and installed exterior, especially for the residential. I know if they are if we're like talking specifically about residential systems, if they are being installed inside, then I know they're required to kind of be in like a fire safe room, probably similar to how your boiler or something is installed in your home. But they definitely are allowed outside. Usually that is the easier way to get these permitted. And when these systems are going inside, especially when they're in occupied places, there's a lot more stringent regulations that are needed. And yeah, so I'm happy to discuss further on that too. If there's something in the code that you're seeing and we might not be, happy to take that offline as well. So next, for the tier 2 permitting requirements. So there is set up to be a process for approval. So you can choose which zoning districts to permit these systems. You know, you're stating that these applications are going to be reviewed and completed within 10 days. You know, if there's a notice for public hearing, if the county planning department needs to be involved. So really set up of how these tier 2 projects are going to be permitted. And then the specific requirements for a permit. There's ones about the utility lines, the signage, lighting, vegetation, and tree cutting, noise, decommissioning, site plan applications, special use permit, and ownership changes. So there's definitely a larger tier of requirements that these tier 2 projects will have to meet when comparing them to tier 1. So regarding the utility lines, basically this law is stating that all on-site utility lines shall be placed underground to the extent feasible and as permitted by the serving utility. It's not always possible for all the utility lines to be underground, but when it's something that's feasible and able, this is saying that they will need to be underground. Next is in regard to signage. So this is basically highlighting the signage that is required by the code, but doubling it, making sure that everyone's aware of it in the law as well. So the sign, if it'll need to, say the type of technology associated with the battery, any special hazards associated, is there a type of suppression system involved, 24-hour emergency contact information in case something is going wrong, and as required by the NAC, if there's a disconnect and other emergency shutoff information, it shall be clearly displayed on a light reflective surface. So this is making sure if the system's installed indoor or outdoor, that people are well aware that this is a storage system and what are the potential hazards that might be associated with them. You definitely don't want an unmarked door in the middle of the field or in an office building that might be granting access to the storage systems for people who are not authorized. Next is the requirements for lighting and vegetation and tree cutting. So the law requires that lighting shall be limited to what's minimally required for safety. and shall be shielded and downcast from abutting properties. You don't just want the lights shining and blaring into your neighbor's windows all night. So making sure you're just doing what's minimally required. And then regarding vegetation and tree cutting, this is something that's also within the code, is that areas within 10 feet on each side of the system shall be cleared. And basically the code itself says 10 feet as a minimum. It is up to the town if they want to move forward with a different requirement. That is your prerogative. And also that the removal of trees should be minimized to the extent possible. Next is the requirement based on noise. So this will require that a 1 hour average noise generated from the battery energy storage system shall not exceed a noise level of 60 dB as measured at the outside wall of any non-participating occupancy. I think they say a lawnmower when it's operating is around 90 dB, and basically an air conditioner under 60 dB are considered quiet. So it's likely if you're in your house and it measures 60 dB outside, you probably won't be hearing it inside, but they do tend not to be overtly loud systems. And then the applicant may be required to provide operating sound pressure level measurements from a reasonable number of sampled locations at the perimeter of the energy storage system to demonstrate compliance. So you can see here that the 1 hour and the 60 are both highlighted. So that is something that the town itself can update depending on, you know, your community's character and what would be best for your jurisdiction. So here is the decommissioning section of the law of what is required. So basically the applicant will be required to submit a decommissioning plan, and this will include the anticipated life of the system, estimated decommissioning costs, how this estimate was determined, and the method of ensuring available funds for decommissioning and restoration, method to keep decommissioning costs current, and the manner in which the system will be decommissioned and site restored. I think a lot of you might be familiar with the decommissioning fund, kind of similar to how it was done with solar. It can be done similar with storage, but basically within the plan, they have to, you know, give you a lot more detail. And regarding the fund, they have to form and get that form and amount approved and determined by the town. And basically whichever mechanism is decided on between the two of you, or the town can decide within the law of what they're basically accepting. And I think I kind of skipped over this for some reason, even though it's probably the most important, is the manner in which the system will be decommissioned and the site restored. So this is another burden that will be put on the applicant, that they'll have to provide to the town of like, how will this system be decommissioned and the site brought back to how it was. So next is the site plan application. So they will have to provide this within their site plan. So I think the more generic, the property lines, physical features of the site, proposed changes to the landscape, the wiring diagrams, equipment spec sheets, general information. They'll also have to provide you their plan for commissioning the system, as well as their fire safety compliance plan. So you're going to want them to have a clear understanding that the system is up to code with regard to fire prevention and fire mitigation. So this should include all of the code compliant precautions and components that will make sure that your system is safe. And we'll go through a few of those in our next section. You also have the operations and maintenance plan and the emergency operation plan. So basically, if something were to go wrong, you'll want to know that there are designated protocol and best practices for incident management, and that your local first responders and fire officials want to know you're looking out for them. So they will have to provide procedures for a safe shutdown if there is an emergency condition, procedures for just inspecting and testing of associated alarms, procedures we follow in response to a notification from the battery management system, and basically what are the emergency procedures. So this is something that will be required from the applicant to provide to you before they're able to get a permit to install their system, which we think is extremely important. And like I said earlier, we do have a class that is more focused towards first responders and incident management, battery energy storage systems. So once again, feel free to reach out to me if that's something that you're interested, or if there's something that want to be done on the county level, we're always happy to help. And then there's also special use standards. So going through usually the Vulcan area requirements. So the setbacks for storage, we just have it complying with the underlying zoning district requirements for principal structures. The height is similar where it's just doing the underlying zoning district requirements. There's also a fencing requirement, shall be enclosed by a 7-foot fence with a self-locking gate to prevent unauthorized access. I think the 7-foot is pretty standard and is what referenced in the National Electric Code, but you do have the prerogative to include whatever you think might be best for your community. And then there's provision for screening and visibility. So basically making sure that you have views minimized from adjacent properties. You want it to harmonize with the character of the property, but not interfere with the ventilation or exhaust ports. So my next section goes a little into fire safety, but a few topics of the model law that we didn't get into is really around, there's also a section for permit time frame and abandonment. So if you issue this permit, it's like this, it'll be in effect for 24 months. And then after that, if they still haven't built the project, they'll have to come back to you and re-up the permit. And also provides information that the storage system will be considered abandoned if it ceases to operate for more than 1 year, which would then trigger the decommissioning fund. And then the other two topics really are around enforcement and severability, which I think are kind of standard provisions that a lot of local officials are already familiar with the other local laws that they have put in place. So the next topic we'll get into is fire safety. And I figure maybe take like a little 2-minute break in case anyone needs to go get some water, use the restroom, any of the above, and basically reconvene in 3 minutes or so. As I know, just myself talking into a computer for an hour is really, really exciting. So give everyone's ears a little bit of a break. All right, I see we have a few questions in the chat, so I'll kind of answer a few of those and then we'll jump in to get into the fire safety. So can NYSERDA help evaluate the various plans required to be submitted with the site plan? If not, is there a list of consultants? So we can't actually review the plans as we're not the permitting authority, so we can't really sign off on yes or no. But I do believe we have a list of consultants that we've come across who've done this. So if you send us a note, we should be able to at least guide you in the right direction. Someone else stated that they're considering requiring the applicant to make an annual in-service training hands-on for first responders in the area. I think that's a great idea. I know as like the emergency operations plan, it is a requirement for them to help train the first responders initially. So I don't think asking that for an annual or every 2 years would be that outlandish. And also if a critical environmental area could be the town aquifer for a reasonable place not to allow tier 2 battery facilities. I mean, that sounds reasonable to me, but would defer to the town as you're definitely more familiar with what your town is and how close the aquifer and you know, how important that is to your jurisdiction. But I don't think that would be outlandish. And with that, we'll jump into fire safety. So far during the presentation, we've started with the building blocks and basics of what are energy storage systems, went into what New York State's goals and policies are, and why, you know, these systems are being deployed statewide, and then touched on the model law and model permit to show how your jurisdiction can basically permit these systems in your jurisdiction in line with your community's character. So next, we're going to go through some of the fire safety requirements through the Uniform Code. So these are probably things that have crossed your mind frequently, but were not included in the model law. And the reason for that is because they're already basically adopted on your local level because they are in the Uniform Code. So we try to avoid doubling down on some of that in the law itself as it's already basically in effect. So the New York State codes are based on the international code. So the International Fire Code, Building Code, and Residential Code, and also the National Electric Code. So these are where all our uniform codes have come from over the years. And I think something that is very unique to New York is the code evolution that's happened here for energy storage. So back in 2019, on the previous code cycle, the 2019 Energy Storage Supplement was adopted that amended the Uniform Code. This added provisions related to the installation, use, maintenance of energy storage systems, and permanent rulings were put in place November 1st, 2019. So what this supplement basically did was skip 2 code cycles of the requirements for battery storage. So we actually have more of one of the most advanced codes for energy storage in the nation. Initially being on the 2015 code cycle, there were very limited energy storage requirements within there. And we were on schedule to adopt the 2018 IFC, IBC, IRC in relation to energy storage for the 2020 code. But basically, the 2018 codes for energy storage still were not up to par of at least what we thought. It wasn't taking into true effect the different risks that are associated with different battery types and depending where they are. So we worked very closely with the Department of State to get them to implement the storage supplement that is now just part of the energy storage code and part of the uniform code at this point. So this is applicable without the need for adoption. Is probably the most stringent code for storage across the states. So as we're talking about fire safety, I think one of the most important things to understand is thermal runaway. So thermal runaway is the largest risk in these battery systems, and this is what the code is trying to prevent from happening. So usually how it works is if there's a battery abuse, that could damage some of the cell, which could lead to off-gassing, which can release to heat releasing, to smoke, to ignition, to fire, to propagation, and basically continue that cycle from one cell to one cell, to one module, to the next module, to one rack to one rack. So that's what's considered thermal runaway. So there are different mitigations that have been put in place through the code, which is like considered more of how can we prevent the system going into thermal runaway if it so does. And if it can't be prevented, what are the different containment that can be done to prevent this from becoming a large fire or risk. I see we have a question, so let me give it a read quickly. So they're asking, where are we going to get all the lithium needed for the mandated increases in storage vehicles and everything else we need, and how recyclable are lithium-ion batteries? And if they are, what percentage of the lithium in batteries can be economically recovered, or do they go to the landfill? So that is an excellent question, and I don't have an excellent answer, unfortunately. I know there are a bunch of different companies that are currently looking to get into lithium-ion recycling. And we did have an expert on as part of our energy storage webinar series that I think we did last spring, which I'll be happy to share the link to that to Carrie, who might be able to give a better insight and informative answer on that one. So continuing with thermal runaway, this is an example of what it can look like in a module. So it could be there is some kind of event that causes one cell to overcharge heat, or maybe it's pierced and damaged, and that basically starts heating up one cell, which spreads to the next and spreads to the next. And then basically using different mechanisms and suppression systems, it's trying to put out that thermal runaway before it moves on to the next module. So this is like the main thing that the code itself is looking to prevent and contain. So continuing off this diagram, you can see here there's a number of components that are built into the system that can prevent, contain, and mitigate thermal runaway before it occurs or once it's already occurring. So these are the different protection methods. So basically in the beginning stage, if there's like a slight battery abuse, there are, maybe the battery management system can prevent it from spreading. Maybe the cell quality is strong enough and basically the damage wasn't bad enough that it can prevent it as well. And as this continues through the circle, there's also off-gassing detection. So you will have gas detectors near the system and it'll recognize if that's occurring and be able to shut the system off or something along those lines. And then as you're monitoring the temperature, there might become a stage where it's too late to prevent thermal runaway from occurring. So you'll have to work on now containing it. So this is where like smoke detection comes extremely important, gas detection, there's exhaust and deflagration venting for these systems, different fire suppression methods, cooling and heat transfer plates. There's specific separation distances that are required and basically having a non-propagation design. So these are all methodologies that are basically included in the code to help prevent or contain if an event would occur. So we'll kind of go through majority of those and you'll see the different systems that are set up for storage to help prevent basically a fire. So this is part of the fire code here. So we're moving into the fire safety compliance that is required for non-residential systems, which will include most commercial and utility scale systems. So as we were discussing the tier 2 systems earlier and that they have to have that fire safety compliance plan, this is what that is really referencing. So these are the requirements that they'll have to show compliance to within the application process. So these are any systems. So these are the energy storage system threshold quantities. So basically it goes through the different technologies, and if the energy capacity of a single module is basically exceeding these thresholds, it will need to go through the fire code and meet all these requirements. So once again, these are mostly those commercial utility size systems. Next is the systems will have to perform a hazard mitigation analysis. There are a couple of key regulatory requirements which are important to discuss for these larger battery systems. And when we talk about these larger systems, the 2020 code imposes stricter requirements for these systems that are over 600 kilowatt hours. So once again, these tier 2 systems need to meet this. The first key requirement here is the hazard mitigation analysis, which is required for tier 2 systems, and that the study is done to evaluate consequences of failure modes seen here on the left side of the screen. So this analysis will evaluate the consequences of failures if there's a thermal runaway in a single energy storage rack, module, or unit, failure of any battery management system, failure of any ventilation system, voltage surges. I also think I have a ghost here because my slide keeps moving faster than I anticipate. So has to look at the voltage surges on the primary electric supply, short circuits on the load side of the energy storage, what happens if there's a failure of the smoke, fire, or gas detection, or fire suppression, or failure of a spill neutralization or containment system. So ultimately, the fire code official will approve the hazard mitigation analysis, assuming the points on the right hand of the screen have been met, so that fires will be contained for a minimum duration of the fire resistance and detected in time to allow occupants to safely evacuate, that toxic and/or highly toxic gases released during fires will not reach concentrations in excess of immediate dangerous to life or health level in the building or adjacent means of egress routes during the time deemed necessary to evacuate, and that flammable gas will not exceed 20% of their lower flammability limit and will be controlled through ventilation of the gases. So these analyses can be reviewed by an engineering firm on behalf of the jurisdiction or a permitting authority to determine the best approach of how to handle a failure. The second key requirement that I want to call out is the large-scale fire test. Where required, large-scale fire testing must be conducted on a representative energy storage system in accordance with UL 9540A or an approved equivalent by an approved testing laboratory. And the test must show that a fire involving one system will not propagate to an adjacent system. It should also show that if a fire does occur, it will be contained within the area for the duration of the fire resistant rating of the room and assemblies. The test must, there it goes again. The test report must be provided to the fire code official for review and approval. There are a few requirements throughout the supplement that can be altered based on the results of the large-scale fire testing, which we'll touch on as we go through this document. But between the hazard mitigation analysis as well as the large-scale fire test that it's required, it's trying to make sure that these projects are being installed as safely as possible. So next, this slide represents the maximum allowable quantities that were discussed earlier in the presentation. If an installer wants to exceed the values listed in this table, they will need to conduct the hazard mitigation analysis and large-scale fire testing to show that the system will be safe. You'll see this requirement in the red box as number 1, stating that the system exceeding the amounts listed in the table on the right can be permitted only with a hazard mitigation analysis and large-scale fire testing. Over in the table on the right, you'll see lithium-ion batteries in the middle showing a maximum allowable quantity of 600 kilowatt hours. You'll see this requirement in the red, you'll see that this is kind of where the tier 2 threshold comes from, is this lithium-ion is basically anything over 600 kilowatts will have to meet all of these requirements. Sorry. So we also touched on this briefly earlier, but the battery management system is considered an instrumental safety feature of the energy storage system. This should be considered the eyes and ears, maybe even the brains of the battery system's health. This device is constantly monitoring the state of health of the storage system and responding accordingly. For example, it can detect a cell overheating and shut it down and isolate it to prevent thermal runaway. If the battery management system were to fail, the system would lose a major safety feature, which is why those UL listings, test protocols, and commissioning are very important. I see we have a few questions, so I'll take some. Is the smoke or gas toxic? Is the first one. We'll get a little bit more into this, but during normal operation, lithium ion batteries do not emit toxic gas, but during an event they might, so they have specific requirements for ventilation. If a spill occurred, what would be spilled? So basically, it would be the electrolyte, but lithium ion is not considered to have a liquid electrolyte like some other systems do, which we'll touch on later in the presentation as well. And then a question regarding what causes thermal runaway. And I think the thing of what could cause thermal runaway will kind of be any abnormality. Obviously, if the system is physically damaged, there's a risk it could go into thermal runaway. It could just be a malfunction. There really could be a few different causes, but that is why there's a lot of requirements, especially regarding the hazard mitigation analysis and large-scale fire testing to ensure that these are being put in as safely as possible. And then continuing on that question, if the battery units would shut down that bank of batteries before it expands to the other cabinets, how does emergency service shut down the system? These systems are required to have a rapid disconnect as well, so they could go that way. But once again, it would depend on the system itself, and hopefully within the emergency operations plan that the applicant is giving to you, that would be a protocol that they would provide as well. All right, so the next that we'll speak about is the size and separation. So basically all systems will have to be segregated into groups not exceeding 50 kilowatt hours, and each group separated a minimum of 3 feet from the other groups and from walls in the storage room or area. Though the fire code official is authorized to approve larger capacities or smaller separation distances based on large scale fire testing. So you'll see a lot of those storage container size projects that can basically be approved if the fire code allows those systems to be closer together, which we'll have I think I have an image later in the presentation where you can actually see what one looks like on the inside, so we can get to that. But basically, this is part of the design of the system to make sure there's no propagation or kind of avoid thermal runaway on a design kind of way. So basically authorizing to approve larger capacities, it needs to be shown on that large scale fire testing that there is not a risk, to increasing those capacities or lowering those separation distances. Here is the maximum enclosure size for these systems. So outdoor walk-in units shall not exceed 4,028 cubic feet. The original code in the supplement just had these 8 feet by 53 by 9.5, but one of the public comments was, why can't it be based on the size of the container, not the dimensions? So that got moved from dimensions to basically the cubic size. Next, here's the general installation requirements for systems that toxic gas during charging, discharging, and normal use conditions. So you'll have to provide that HVAC system or some way to ventilate the hazard gas out of the system. But like I said previously, lithium ion does not off-gas toxic gas during normal operation. This is also within the code, the fire remediation. So the energy storage owner shall mitigate the hazard or remove damaged equipment from the premises to a safe location. The owner shall dispatch fire mitigation personnel to respond to a possible ignition or reignition of a damaged storage system and remain on duty after the fire department leaves the premise and until the damaged storage equipment is removed from the premises. So they have to provide these on-duty mitigation personnel shall have the following responsibilities: fire watch, notify the fire department if fire occurs, maintain until decommissioning is finished, and evacuate building if needed. Yeah, and that's a picture of my brother in the FDNY. Just like to throw that in there. So yeah, he doesn't know, but he's famous around New York State now. So next is the electrochemical energy storage technology specific protections. So something this code really looks at is requiring different requirements based on the battery technology. And we'll go through each one of these compliances that are required. First, it's the lead acid battery. So that requires the exhaust ventilation, the spill control and neutralization, explosion control, safety caps, and thermal runaway. Similar for the nickel-based batteries. Lithium ion does not have a requirement for exhaust ventilation or spill control. There's no requirement for exhaust ventilation. As I've stated before, when it's normal operation, it does not off-gas toxic gas. Similar to the spill control and neutralization, the electrolyte of lithium ion is not a liquid electrolyte, which it is in lead acid. So there's no requirement to have that spill control. There is a requirement for the explosion control, and we'll go into that more in depth when we get to that slide. And then you also have the safety caps and the thermal runaway requirement. So here is the exhaust ventilation, which I stated is required for like lead acid batteries. So the ventilation is designed to limit the maximum concentration of flammable gas to 25% of the lower flammability limit, or provide that continuous ventilation. There needs to be standby power for a minimum of 2 hours, and exhaust ventilation shall be supervised by a central or remote station. As part of the exhaust ventilation requirement, a gas detection system is required to monitor the levels of gas in the unit. This will trigger appropriate ventilation and inform operators of unusual levels of off-gassing. Any failure of the gas detection system will also trigger a trouble signal to the battery management system. So here is the requirement for spill control and neutralization. Like I had said before, this is required for batteries with liquid electrolyte. So like I said, lithium ion doesn't have a liquid electrolyte. So this is not a requirement for those projects, but it is for lead acid projects. Next is a requirement for explosion control. So explosion control can be handled in 2 ways: defloration venting or prevention. Most lithium ion systems will have defloration venting panels that will manage the pressure blast wave that is produced in an explosion. The blast wave will be sent through the venting panels and should maintain the integrity of the container. These panels' venting directions should be directed to areas that will not interfere with the fire department operations. This is where, as discussed earlier, while not required for normal operations, exhaust ventilation can be used for lithium ion systems as part of their explosion prevention. So this is actually an image of a site in Brooklyn that we had visited, I think like pre-COVID, however many years ago that was, where they have these ventilation, these panels right here. They actually, if the pressure builds up enough in this storage system, basically how these are angled, it would push all the gas out of here and would go up. So it wouldn't be pushed down towards the firemen if they were there or anything with those guards. So this is actually a really well utilized and designed panel for this. Next, also within the explosion control is like fire suppression systems as well. So this is in the same system that I just talked about in Brooklyn. So they have a gas system that is set up throughout the unit, as long also with water. So you can see the both of them work in tandem. So they have their clean agent that would come out of this gas one, but then they also do have the water as well. So at the end of the day, the only way you're really going to put out a battery fire, if it's, you know, it's past all points of coming back from, is by just soaking in water. And with these containers, if they have not been opened, or the doors, basically these water from a dry pipe will come into the system and then completely fill the storage container and dissipate that. So that's another mention of fire suppression. So something that this code does that's a little different than other codes is, in addition to taking into consideration the different types of electrochemical technologies, they also look to where are these projects being installed. So they define 4 separate locations within their code. Actually, it's 6, but we'll just discuss 4 of them at this point. One is a dedicated use building. So this would just be a large building that the only thing in there is energy storage. I think it allows for a 10% of the building to be for admin, but basically, as it states, the dedicated use of this building is for energy storage. And then there's the non-dedicated use building, which is any building that is not a dedicated use. So normally your colleges, your office buildings, anything along those. So those non-dedicated use buildings, they have more stringent requirements as there's human health in that building. So they want to make sure everything that's installed is installed as safely as possible. Not that they're doing the opposite for dedicated use, but there's different risk when it comes to the proximity of people in the building. And then for outdoor systems, they're also defined 2 separate ways in the code: outdoor near exposures and outdoors remote. So they have different requirements for the remote systems than if they're near exposures. So this is an example of some containers. I think it's out in San Diego, installed by the utility. And this is a 120 megawatt installation. And basically you can see that they have the security requirement here. So you have the fencing requirement, they have the HVAC as well as exhaust ventilation as their explosion control. They have a means of egress, and it's in line with the maximum enclosure size. So this is an example of a walk-in unit. You can kind of see how all the battery racks are loaded against each side of the wall. They have a suppression agent, clean agent in here as well. HVAC system, battery control panel. So just kind of giving you an idea what some of these systems look like. This is the battery energy storage cabinet. So these are pretty popular. I think on the next slide might give you an idea. So this is an example of an outdoor cabinet system. I think this is probably maybe 2 of your dining room tables of the size of it is, to kind of give you an idea. And this is a remote installation, which with remote installations, size and separation isn't required. That's really an indoor and near exposure requirement. So again, for outdoor installations, they need to have at least 10-foot clearance from lot lines, public ways, buildings, basically anything hazardous. And then once again, this is just for exterior wall installations. They have specific maximum capacity units, have to be in compliance with the fire code besides that. And basically they need some individual unit separation. They can, lower separation once again, based on large scale fire testing. So that is really the majority of the presentation in regard to the model law, as well as fire safety for battery energy storage systems. This next 2 slides really is highlighting the Build Ready program, which is trying to advance large-scale renewable energy projects by identifying sites that are consistent with the state's permitting standards and are made build ready for private renewable energy developers. So this is something that, you know, if your town or has any underutilized land, might be something that you're looking to build solar on. NYSERDA is trying to acquire interest in lands and like basically do a lot of the development for you and sell it back to private developers. So it could be an opportunity for your local jurisdiction to, you know, turn underutilized land into basically renewable energy. So if this is something that might intrigue you, I've just provided a little bit more information about them. They're just engaging with local communities across the state right now to for prospective sites for large-scale projects. So feel free to reach out to them if you think you might have a site that would be beneficial. But really, I'm happy to take any more questions. I hope this was beneficial for you today. And really, like I said earlier, take this as an introduction to myself and my team. And we're happy to, you know, field any questions you may have, either now or if you stump me, I'll do it later. Keep us busy. That's what our jobs here at NYSERDA is, to be an asset to you all. So that's really all I have. If there's any other questions.
Seems kind of quiet. And we may be done. And if anyone has a question, maybe not tonight, they can always send me an email and I can always get in touch with Candace.
And Carrie, I can share with you some few additional links and resources and my personal contact information that you can send out to everyone tomorrow as well. So basically have it all at your fingertips without having to look too hard.
Absolutely. I think that would be great. I can do that along with the presentation itself.
Perfect.
Hi, this is Johanna Kiernan. Can you hear me?
I can, yes. Joanna, how are you?
Okay, thank you. The town of Blooming Grove is putting in some solar arrays. So a lot of this information was very important. I've been on 1 or 2 of these seminars already, and I want to thank you again for doing this. I think it's very pertinent. I know it was a tremendous amount of information, so I know I myself will appreciate it if you send out those slides and I have time to sit down and digest them again. It's even more important, I'm on the planning board, so these are very timely issues for us. So again, I want to thank you and I appreciate all your hard work on this. I know it's a lot.
Yeah, absolutely. We're happy to get out there and give you guys all the information that we can. And, you know, we want to be there supporting you and make sure you're making the right decisions for your community. So happy to be here and help out. I know it's definitely a lot of information. We do also have, which I'll provide Carrie, is that we did a 4 to 5 part series about a few months ago, I guess last spring maybe, on battery storage and a bunch of different topics which I'll be sure to include the link over to Carrie when I send it to her tomorrow to provide to everyone, because, you know, sometimes just reading the slides isn't the same as, you know, having someone present them. So that has a wide panel of different experts discussing them. So it's definitely an interesting listen if you have the time.
We also do have Kate Schmidt, who is a planner with the Orange County Planning Department, in with us tonight. I'm not sure if anyone may have questions regarding the 239 process thus far. We may not be able to provide answers, but we can definitely take questions to research.
Carrie,
All
just a
right.
quick note. Thank you very much.
Thank you. All right, if there's no more questions, I'm going to bid everybody a good night.
No more questions, just compliments. Thank you all.
Thank you.
Yes, compliments. Thank you.
Thank
Thank you
you.
so much. That was very informative. Thank you.
Absolutely. Thanks for having me, and everyone have a nice night and good weekend.
Stay
Have a
safe.
Thanks, Candace.
Same.
Bye.
Thank you.